Example 2. Solve the system of equations. Here we have 3x minus 6y equals negative 4 as the first equation, and the second equation is 5x plus 4y is equal to 5. Okay, again, we are interested in finding the x value and the y value that you plug into both equations, and both equations end up in true statements. Okay, again, I'm going to do elimination here. Okay, so for this one, it's not as obvious how to eliminate. Okay, so if you scroll back to example 1, it was a bit more obvious as to which variable to eliminate. You were comparing 14y with negative 7y. So if you just multiplied that negative 7y by positive 2, that term would turn into negative 14y, which would cancel with the 14y. So here, if you're comparing your x pieces and your y pieces, it's not as obvious. Okay, so it's kind of a tie here as far as difficulty. Okay, as in terms of either eliminating the x or eliminating the y. Okay, 3 and 5, those are the coefficients of the x's. Okay, how am I going to cancel these guys? Same thing with negative 6 and positive 4 with the y's. How am I going to eliminate these guys? Well, what we're going to have to do here, okay, is just pick one of the variables, and we're going to actually have to adjust both equations. Okay, we're going to have to multiply both equations by something in order to get cancellation here. So since we eliminated the y's last time, I'll do one where we eliminate the x's. Again, it doesn't matter how you do it. Okay, just try to go the route that is easiest if you see it. Okay, so let's focus on our x terms here. We've got a 3x versus a 5x. Okay, I want them to cancel, meaning I want the same coefficient, okay, but one positive and one negative. Okay, well, the easiest thing to do is kind of use the coefficients against themselves. Okay, the first equation, I am going to multiply it by this other number, 5. Okay, so if I do that, and you're going to have to distribute the 5 throughout the equation, that's going to put a positive 5 here, or a positive 15 here, 15x. Okay, so that would result in a 15x. So if I'm doing this, okay, how can I adjust the second equation to put a negative 15x here so that the x terms would cancel? Well, since I already have a 5x, I'm going to have to multiply by negative 3 to get a negative 15x in that position. Okay, so that's what we're going to do here. We're going to multiply the first equation by positive 5, and then we're going to multiply the second one by negative 3. Okay, so this does happen where you have to adjust both of the both of the equations. Okay, so here we go. Let's take the first equation and distribute the 5 throughout. Okay, so 5 times 3x is going to give us the 15x, it's positive, and then distribute here. 5 times negative 6y is going to give us negative 30y, and then on the other side of the equal sign, you're going to have 5 times negative 4, which is negative 20. Okay, so first equation has been adjusted. Now we adjust the second equation. We're going to multiply negative 3 throughout. So negative 3 times 5x is going to give us negative 15x. Negative 3 times 4y is going to give us negative 12y. And then on the other side of the equal sign, we are going to have negative 3 times positive 5, that's negative 15. Okay, and then we add. Okay, you always adjust your equations and then you add them together. You're always adding. Okay, well, the way we've done this, our x's cancel out. I've got a 15x positive. It cancels with the negative 15x. You have to have a positive and a negative. Two positives don't cancel, two negatives don't cancel. All right, so now we keep adding. Okay, so what's going to happen now? Negative 30y plus a negative 12y. That is going to be negative 42y. Okay, on the other side, we're going to have to add again. What is negative 20 plus negative 15? Well, that is negative 35. Okay, so we can solve for y. There's only a y in this equation. So we're going to divide both sides by negative 42. Okay, so negative divided by negative will turn positive. So y is going to be 35 over 42. Okay, kind of a strange answer, but that's okay. You can get fractions as your answer. Let's go ahead and reduce this fraction. Both of these numbers are divisible by 7. So 35 divided by 7 is 5. And then 42 divided by 7 is 6. Okay, so there you go. The y value here has to be 5/6. Okay, we still have to get x. Okay, so now that we have the y, we're just going to go back to one of the original equations, does not matter which one, and we're going to plug in this specific y value. I'm just going to use the first equation. So 3x minus 6y is equal to negative 4. We're going to go ahead and plug in the fact that y has to be 5/6. So we're going to get 3x minus 6, substitute the y value, which is 5/6. Okay, this has got to equal negative 4. Okay, so here we go. This is going to give us 3x minus, okay, we have a 6. This is 6 over 1. So we have a 6 in the top. It cancels with a 6 in the bottom. So the result is going to be a minus 5. Okay, this has to equal negative 4. And then we can solve for x. So I'm going to add 5 to both sides. I'm going to get that 3x is equal to positive 1. Divide both sides by 3. So the x value here has to be 1/3. Okay, so we are done because we have both the x and the y. Okay, again, you can substitute both of these values into both equations and you should end up with a true statement. That's how you can check yourself. Okay, so I'll go ahead and write down the answer here. So you can just specifically state each variable. So x is 1/3, and then y has to be 5/6. You can also write it as an ordered pair. Always put x first. So x is 1/3, y is 5/6. Okay, there's your answer. Okay, really quickly, we've been doing the elimination method, but I want to kind of just mention the other methods that you can use to solve a system of linear equations. Okay, so we've discussed the elimination method where you adjust the coefficients. Coefficients means numbers in front of the variables. You adjust the coefficients either in one or both equations, then you add them, and then you use the specific value of the variable you found, you plug it into one of the equations to get the other variable. Okay, in substitution, what you do in that method is you solve one of the equations for one of the variables, and then you substitute that statement into the other equation, and that will allow you to solve for one of the variables, and then it's like the end of elimination. Then you take the value of that variable, plug into one of the equations to get the other variable. Okay, something that we can do because we are dealing with two equations and two variables, both equations have the format ax plus by equals c. Like I said, they are lines. So what you can do is transform each equation into y equals mx plus b form. You can identify the slope, the y-intercept, and you can end up graphing each line. And then the solution to the system is going to be where the two lines intersect. Okay, so that's kind of a cool method as well. The method I don't have listed on here, that's matrices. That's actually how your book explains it, is through the matrix process. So a matrix is kind of it's like an array of numbers. Okay, so it would have this format. Okay, so these blanks would have numbers in it, and you'd have to operate on that matrix. You keep changing it to equivalent matrices until you get to the final one, which will include the answer. Okay, I chose to keep it simple instead of teaching you matrices because matrices, students typically struggle with it, and I just wanted to, since we're keeping it simple with these smaller systems, I decided to keep it simple and go with elimination. But you're welcome to try any of these other methods.